Hello everyone and welcome to your week 4 tutorial. Please remember that the PowerPoint slides for week 4 tutorial and week 3 tutorial, it's in one PowerPoint slide itself, and it is provided to you under modules and within the lecture tutorial content for week 3. So the three main things which we are going to be covering in today's tutorial in terms of bivariate analysis is Pearson's correlation, independent samples t-test, and Pearson's Chi Squared test. All right. As indicated previously, bivariate analysis, what does it mean? It means you have at least one IV and one DV. For instance, smoking causes cancer, meaning you have data on number of people who are smoking and you have data on number of people who have cancer. Okay, so just an example, but yes, you need two minimum variables, which is your IV and your DV. All right. So now we'll talk about Pearson's correlation. So Pearson's correlation, if you remember your last week's tute, I talked about parametric test and non-parametric test. So Pearson's correlation is a parametric test which is used for normal distribution. And we even spoke about how to gauge normal distribution, right? So visually, by looking at a histogram, which looks like a bell-shaped curve. Then I told you about the KS and SW test. And then the other way is to see the difference between the mean and median. But I didn't teach you that because, as I said, there are many ways. If I have to cover all of that, then we will be keeping epidemiology on one side and we'll start talking about quantitative statistics. So let's not do that. But yes, sufficient basics were covered in your week 3 tute. And moving forward, just as a highlight, as a flagger, your Pearson's correlation is a parametric test. All right. And in Pearson's correlation, if you remember, I had said two continuous variables. So your IV is continuous and your DV is continuous. I know these actions which I'm doing are really silly, but trust me, if you're very new, and a lot of you have emailed me that you are very new and you're quite apprehensive about quantitative data analysis, these tricks help you. Okay, so no shame in learning. Let's learn what is best for us. Okay, so yes, there is one IV and one DV, so there are two variables in Pearson's correlation. All right, and the relationship in Pearson's correlation, both of these variables are continuous in nature, and the relationship can be either positive association or a negative association. Positive association is also called as directly proportional. Negative association is also called as inversely proportional. All right. So positive association can be something like this, which is over here, hovering my mouse over here, which is high sun exposure, high vitamin D levels. Makes sense, right? Similarly, in a negative association, you can have high sunscreen usage, low vitamin D levels. And I'm talking about your blood levels of vitamin D when you do a blood test. All right. So makes sense. So you can have two sorts of association in Pearson's correlation. And the symbol for Pearson's correlation is a small letter R. All right. So it's an R. Okay. So the answer, when you do a Pearson's correlation in SPSS, you always get an answer which is between -1 to +1. All right. And we'll look at the answers. You'll get a better idea then. All right. So Pearson's correlation, the value R is a standardized value, meaning in epidemiology, basically what we do is, for example, if you are doing your assignment 3 topic, which is, you have to do an intervention sort of a topic. And I gave you an example on, I don't remember exactly which example I gave you, but I think it was to do with calcium supplementation and the risk of fracture in, say, menopausal women. All right. So now if you have a topic like this, and maybe you have collected, say, 20 to 30 articles, all those articles which have done Pearson's correlation, you can actually compare these values. You can say that, say, Smith et al. Had a very weak Pearson's correlation value. The association between calcium supplementation and prevention of osteoporosis was very weak in his study. Whereas, say, Colleen et al. Found that a very strong association. All right. And when we talk about association strength, I had explained to you in your reliability and validity the association scores, which is if you look at the Cronbach alpha, you know how I said that, say, if it is say 0.3, the association is 0.3, it is moderate, 0.9 is very, very good. So the same phenomena applies over here. Greater the number, stronger is the association. And what do I mean by stronger is the association? Meaning, if in Colleen's study, okay, we said Colleen et al, right? So we said he had very good association. So probably his Pearson's correlation value was R is equal to say 0.9 or 0.8, okay? So meaning 80, if you convert that 0.8, it becomes 80%, right? So basically in layman terms, what are we trying to say? We are trying to say that in menopausal women, the risk of fracture is prevented by taking calcium supplementation, and calcium supplementation is explaining 80% of this relationship, okay? Meaning calcium supplementation is the variable which is predominantly responsible. 80% of it is responsible for preventing the risk of fracture or osteoporosis among these postmenopausal women. Okay, so that is what it means by explaining variance. So basically, say the risk of fracture or the risk of osteoporosis, say minimizing this risk is possible by 80% with the intake of calcium supplementation. You will say, what about the remaining 20%? There are other variables which may explain the risk of fracture prevention. These 20% would be responsible by other variables. It could be something like physical activity. We all know that strength training, it helps with calcium deposition, and that in turn will help in fracture prevention and therefore the risk of osteoporosis. So maybe 20% is responsible because of exercise, or that 20%, within that 20%, say maybe 3% is responsible for non-smoking. As you know that there is a very strong relationship between individuals who don't smoke, they have a better risk of, they have a better chance for not getting osteoporosis. So many factors. It could be say any other factors. It could be say yes, sun exposure. Maybe it is indirectly the levels of vitamin D in their blood, which are a protective factor for osteoporosis as well. All right, so this is what I'm saying, is that with Pearson's correlation, it gives you an indicator of the strength of the relationship between the IV and the DV. I hope this makes a lot of sense, guys, because it is very important to understand the difference between effect size and significance. And we'll be briefly talking about that in one of your lectures. All right. Okay, so now moving forward. So very important, guys, when we say there is a correlation between say sun exposure and vitamin D levels, this does not equal to a cause and effect relationship. Okay, only by simply doing Pearson's correlation you cannot say, oh yes, sun exposure, say low sun exposure causes low vitamin D level. No, as I said, cause and effect relationship can only be proven when you have a rigorous study design. And I think by now I have spoken enough to drill it in your heads that it is the randomized controlled trial design, all right, which can establish a cause and effect relationship. And for you to establish a cause and effect relationship, even when you say you have done a randomized controlled trial, for example, okay, but even after doing a randomized controlled trial, if you just do a simple Pearson's correlation, not enough to establish a cause and effect relationship. Because Pearson's correlation, it does not consider confounding variables, meaning all those other variables which may also be responsible for the low vitamin D levels. In this example, the sun exposure and vitamin D levels. So low vitamin D levels may not only be because of sun exposure, it could be because of cultural say and ethnic background. Why? Because we know that individuals who are, say, from not all Muslim cultures, but certain individuals in Muslim cultures, they practice, say, wearing a hijab, they practice wearing a burqa, where you're covering a lot of your body part, meaning less exposure to the sun. So in one of my studies, this was seen that the women who were wearing burqa, they had lower vitamin D level than the other women who were not wearing a burqa. Okay, not that we want to tell them to not wear a burqa. There are many other say culturally appropriate and respectable ways of say supporting their vitamin D levels. But this is what I'm saying, that there are many confounding factors which could be responsible for low vitamin D level of an individual, but this is not accounted for by a simple bivariate association. As I said, the first step when you do quantitative data analysis comes is the descriptive statistics, like we covered mean, median, say percentage, 20% boys, 40% girls, all of that. So first, when you have a data set, you start with descriptive analysis. The second thing which you do is bivariate analysis. But bivariate analysis is only looking at two variables, IV and DV, all right? And therefore, you do multivariate analysis, okay, which is looking at a lot more variable. And one of the most well-researched and most popularly used multivariate analysis technique is regression. All right, so you have linear regression, you have say bivariate regression. So there are many types of regression as well, but regression accounts for a lot more variables. And if results are significant using multivariate regression, then you may have enough confidence in saying that there could be a cause and effect relationship. Beyond regression comes modeling techniques, like you have various softwares such as MOS, which does structural equation modeling. With that, you have greater confidence in proving a cause and effect relationship. Be mindful if you have a strong study design to start off with, such as an RCT. Okay, so this is what I'm saying. There are many factors going on, guys, before we establish a cause and effect relationship. So be mindful that when you're doing a simple Pearson's correlation, the best terminology to use is associated correlated. Okay, don't use cause, all right, because that's not right, all right, or leads to, no, okay, because those are more say causal terms and we don't want to use those. All right, so yes, and yes, as I said, that bivariate association, they are not the most rigorous. They are just a starting point to do your statistics. So basically, the association between IV and DV in a bivariate analysis, which is a Pearson's correlation, it could be bidirectional in nature. Meaning, for example, if I have two variables over here, okay, and I have used the example when we are actually going to practice this in SPSS. So you have mothers, but I'll explain you what these variables are. So basically, these variables, they come out of my PhD study, all right? And the current research which I'm doing, you know, which is a multi-centric study that I shared with you, which is happening in Australia, India, and Malaysia. So currently, that is how I'm doing the study, which is looking at picky eating from an environmental point of view and picky eating from a genetic point of view, right? So this pressure feeding is, say, one of the risk factors for children becoming picky eaters, but this pressure feeding, say, is an environmental determinant, or in simple words, say, potential environmental cause of picky eating. Okay, that is how it can be looked at. So basically, what is pressure feeding? When mothers are pressuring their children to eat all of their veggies on their plate or all of the fruit which has been given to them. So you don't, with 99% of the time, you don't need to pressure a child to finish their hamburgers or their fries, right? You need to pressure children to finish their fruits and veggies, particularly your green leafy veggies, so on and so forth, right? So over here, the action of the mother coercing the child to finish all foods on their plate or veggies on their plate, this action is called as pressure feeding, all right? And you have, say, sophisticated questionnaires to measure this, all right? So over here, what I'm trying to say is mother's pressure feeding strategy is, first I'll just explain you in simple terms, so don't catch my words over here, is causing picky eating in children. Okay, meaning now when I say picky eating in children, it is the child exhibiting picky eating behavior, where the child is like, yuck, I don't want to eat, and child pushes the plate away, and child throws tantrum and throws food and stuff like that. So all of that is picky eating behavior. Or child will take, say, like 4 hours to finish that veggies in his or her plate. So all of these are, say, traits and signs and behaviors of a child being a picky eater. All right. So basically what I'm trying to say is that over here, these two variables, mother's pressure feeding technique and the child being a picky or a fussy eater, there is a bidirectional relationship between them. Meaning we can say that no, because the child is throwing temper tantrums and the child is taking 4 hours to finish the food on the plate, or the child is just playing with the peas and throwing it here and there like marbles. So basically it is because of because of the child's behavior, that is why the mother has to pressure feed. So there could be an argument the other way, where in this argument your picky eating becomes the IV, that the child's behavior is compelling the mother to pressure feed the child. Okay, but it could be the other way around also, where you are saying no, it is because the mother is compelling the child to eat, that is why the child is exhibiting a picky eating behavior. So in this case, your picky eating can become an IV, your picky eating can become a DV, and similarly pressure feeding can be an IV, pressure feeding can be a DV, depending upon what your research question is. This is called as a bidirectional relationship. To prove whether pressure feeding is the one which is causing the fussy eating behavior, you need a very strong study design. Not just an RCT, but you may need to do, say, a longitudinal study design to see whether it was the mother's, say, feeding technique or the child's eating behavior which caused what. All right. So that is a very different area now, which is more, say, more in terms of research methods, which I won't cover over here. But basically, I just want you to understand the concept that the main thing over here, the summary take-home message is that Pearson's correlation is not a sufficient test to establish a causal relationship, meaning a cause and effect relationship, because it does not control for confounding variables, and it cannot identify the direction of the relationship. Relationships could be bidirectional when your variables are as such, like pressure feeding and picky eating. Okay. So yes, guys, I hope it all makes sense. I'm trying to make epidemiology as simple and as relatable as possible, because when you can relate to a subject, that is when you learn best. Okay, even if it is a theoretical subject such as epidemiology, teaching you the practical side of it, like teaching you how to calculate scores, how to calculate the things which you have learned till now, like odds ratios, attributable risk, mortality rate, it just makes the subject more hands-on. It just makes the subject more relatable. And especially when I try to connect the dots between how can these attributable rate, mortality rate, where do you find them in the real world? How are they used? That will help you to connect with the subject. Just teaching it like black and white, like a textbook, will make it really boring, and you won't be able to identify the applicability of the subject in real life. Okay, so that is always my intention when I teach students any new subject or any subject per se, whatever subjects I teach, I try to find the transition between what are they learning in the classroom, and if they are thrown in real life, where will they see this application of this information. Okay, so when you connect this bridge, life becomes much more easier. Okay, so I hope it's serving the purpose. All right, so this is just an FYI, guys, that as I had explained previously, that Pearson's correlation is a parametric test, but the other twin, you know how we had the twin analogy, where we had Pearson's correlation as the, say, a good twin, and non-parametric test where the evil twin. So the evil twin for Pearson's correlation is Spearman's correlation, and that's a non-parametric test. Okay, then you have something as Kendall-Tau test, which is again non-parametric. It is same as Pearson's correlation, but basically you use it when your sample size is really small. Okay, so less than 30, for example. So generally 30 is kind of, say, the rough rule. But yes, for instance, just don't go by that. If you are planning to do research with your supervisors, obviously you will be doing with supervisors only. Basically what I'm trying to say is, if you're planning to do a proper research in future, it could be, say, a PhD degree or honors, that is when your supervisor will guide you regarding the statistics as well. Okay, so if it's some supervisor like me who's like who loves quantitative statistics, will make your study very fun. Okay, so yes, what we will be practicing in SPSS after I cover a bit of theory is Pearson's correlation. So we will be doing it in practice, all right, and looking at how the SPSS output looks and how do you interpret that as well. All right, so guys, we will practice Pearson's correlation very soon. but I'll just show you how do you write the results of Pearson's correlation. Guys, this is where I see a lot of students struggling, that they do the test, okay, the Pearson's correlation test in SPSS. You have the output. First, they find challenge, the biggest challenge they have is how do you interpret the output? Okay, so that will be covering, and hopefully that will help you. But then the second challenge they have is they don't know how to appropriately word these results in a scientific manner. Okay, so that is where this slide comes in to help. Is, for instance, the example which I have given in the SPSS, which we will be doing, is between the variables from my PhD study, which is mother's pressure feeding practices, the mother coercing, the mother pressure feeding, and the child's picky or fussy eating behavior. Okay, so this is how you would word it. So I'll slowly read it out to you because it's important that you write your results in a correct manner. Okay, so there was a significant positive association slash, I have written a relationship, because as I said, do not use the word cause or leads to, okay, things such as that. So the most appropriate word to use are there was a significant positive association, which is right. Okay, so there was a significant positive association between mother's pressure feeding practices and children's fussy eating behavior. Okay, meaning more pressure feeding the mother did, the child exhibited more fussy eating behavior, meaning they are directly associated. Okay, I told you about direct association and inverse association. This is direct association, meaning pressure feeding increasing, fussy eating increasing. Both are going in the same direction. All right. And in your SPSS result, how do you know whether the association is positive? This is a positive association when your R value is positive. Okay, so your R value needs to be positive, which is 0.34. In this case, there is no minus sign. If this was minus 0.34, what would it mean? It would mean that as pressure feeding increases, fussy eating decreases. Does that make complete sense now when I talk about, say, positive and negative association? All right, this is how you figure it out when you look at your SPSS output. Okay, so a positive R, meaning the study is saying, or the result is saying, that more pressure feeding, more fussy eating behavior. Then the p-value over here I have written is less than 0.001. Now guys, this is a very common mistake which I have seen among my students as well, which is when you will see the SPSS output of this, you will see that the p-value in the SPSS output is 0.000. Okay, whenever you have 0.000, that is not how you write the answer. You would write this answer as less than 0.001. Okay, so that is very important. All right, the other way of writing the same, and see, 2 decimal places I have written over here, because see, now that would depend upon your supervisor, the manuscript in which you are publishing. So all of that will depend, but generally I keep my results to 2 decimal places. If you are following a particular manuscript, like if you are trying to publish a paper, they will have their own guidelines, which is different. But the standard thing is try keeping it till 2 decimal places if you're not sure. Okay, it's easier to remove 1 decimal place rather than to add it by doing all of your results again or going through all of your output. Okay, so that's a safer bet. All right, then the other way of writing the same result is higher pressure feeding was significantly associated or correlated. Correlated is the other word which you can use, okay, which does not indicate causal relationships. All right, so high pressure feeding was associated with higher fussy eating. That's also a correct way to write. Okay, so over here again you have the R value and the P value. Writing Pearson's correlation results is like super simple. That's why I started with Pearson's correlation, taking baby steps. All right, so again, just over here, don't use the words such as leads to, causes, influences, because that's not right. Okay, we are not, as I have explained you very, very well, why it is not right. Okay, so see, this is what is very important, guys, is that rather than I just telling you in Pearson's correlation, when you write the results, don't use the words such as lead to, causes, or influences. You'll be like, okay, but then you'll be like, why? All right, so Guys, very, very important for you to remember and register something for lifelong. It's very important to understand the whys of things, the hows of things. Okay. So that's how I have learned, and that's how I try to honestly teach, which is teaching you why is it that it is not right to use the word cause when you're writing results for Pearson's correlation. Now you know why. Because you have been given these n number of reasons over here, but you have been explained these reasons as well. So that's why you know the argument behind why it is not right to use ABCD terms. Okay. So that's very important when you're learning something. And if you want to register it for lifetime, understand the underlying reasons for it, then you will never forget that knowledge. Otherwise, it will just be memorizing, and you may be very smart, you may remember it for 6 months, but then you'll be, then it just won't make sense to you and you will eventually forget. Okay. So that's why it's important to understand the underlying reasons. Okay. So now again, we'll cover the theory of t-test and we'll be practicing as well. So rest assured, we will be doing the real practice also. Okay. So as I said, guys, this year, because of COVID, I have made all of the lectures and the tudes say online, but hopefully in 2021, hopefully, okay, things will be better. And then I definitely intend to have, say, face-to-face lectures, but definitely face-to-face tutorials, because then we can do all of this within the computer labs. Okay, and I can go around and I can see what you're doing and what your challenges are and stuff. Over here, I'm just doing everything for you and making it easy. But at that time, I'll make you practice. Okay, of course, I'm also giving you the activities over here at the end, but you know how it's different, right? When you have like a instructor, someone to like, mentor you immediately on the spot. Okay, so don't worry, I'll be doing this all, but we are making the best of the situation. And trust me, I try to make my teaching style very engaging. So like, I don't like talk like a news, like I'm reading a newspaper where you will sleep. Okay, so I try to make my lectures very engaging as well, so that you gain the maximum out of this situation that we are in. Okay, so we are all in this together. All right. Okay, so now t-test. So what does t-test do? T-test compares mean value between two variables. Now mean values, guys, it means that average values. Okay. So for example, as I said, like, mean is nothing but average. So I have my class, okay, and I teach epidemiology to my class, right? And then you may have instructor B who teaches epidemiology to other class. All of you are at the same level, okay? So all of you are taking 9594 epidemiology, so same level. All right. So then the instructor B may have average of his class. So out of 100, maybe his students overall on an average scored 70%. Okay. And let's make our class a winner. All right. So in this example, out of 100, let's say our class, so this my team, my comrades, you guys scored around 85%. Okay, so on an average you are 85%, they are 70%. But is this statistically different is the question, and that is the question what t-test answers. See, as an early career researcher, this is very important. What students do is they assume that because one is 70 and one is 85, they say, oh, there is a significant difference. Like say Rati's class scored really high because they are 85%. So this is significantly different. No, you cannot use the term significantly different or Rati's class scored significantly higher. You can only use the word significant when you have actually done a statistical test to prove significance. Significant comes with p-value. So as long as you do not have a p-value, which is an indicator of significance, you cannot use the term significance. Okay, you can only say the Rati's class had a higher average rating of 85% and this class had a lower one. Yeah, because those are numbers and that is what they are telling you. But you cannot say Rati's class scored significantly higher if you haven't done a statistically significant test. Okay, because see guys, there are many reasons as to why you may have 85 somewhere, meaning my class, and 70, and when you do a statistical test, you may have a non-significant result. And it could be because of many reasons. Why? It could be because of the sample size. Does it have enough power to, like, means give you a statistically significant result? What if, like, the students in my class were only 10 students and the student in his class were, like, say 70 students, and out of these 10 students I'm like very happy cherry Mary saying that my class scored 85%. But hang on, this is not giving us sufficient power, and your statistically your output may be non-significant. Okay, or maybe there are several outliers. Okay, and they could influence the results becoming non-significant. There are many reasons as to why your 70 and 85 still may be not significant to give you a significant result. Okay, the p-value being significant. All right, so for you to use the term significantly different or significantly not different, you need to do a test. Okay, and that test is your t-test. So t-test used over here when you have two variables. Okay, again, everything we are talking about today needs to have two variables. But in t-test, you are comparing the average values, the mean values. Okay, and in t-test, remember your IV, like say for example, you want to see the gender and serum vitamin D levels, meaning boys and girls. Oh, and that's the example I've given over here. Okay, that's good. So, all right. So, say serum vitamin D levels. No, I have given a slightly different example over here. Okay, you have two groups over here: iron supplementation and non-iron supplementation. By the end of this, guys, don't be tired of my nutrition examples. Okay, so I know I use everywhere these tiny little nutrition examples, but just think of this related to your field. Okay, so if say you're a biomedical student, like and you are focusing in microbiology, think of something like, okay, lactobacilli containing group versus a control group. Be happy. All right, so it's just that something, this is intuitive in me, so I use nutrition examples, but the concepts are applicable everywhere. All right. Okay, so over here I'm saying that you have two groups. Okay, your intervention group is receiving iron supplementation, which is say red color pill. Okay, for example, and you have a placebo group which is also receiving a red color pill, but it is nothing. It's just like a pill which has no nutrients in it. Okay, think of it like that, a placebo group. All right, so it's just a sugar pill maybe. Okay, and sugar is not going to increase your iron, right? So over here you have these two groups. So these two groups are your independent variable because you want to see the effect of intervention on their blood iron levels. Okay, to make it very, very simple. So you have serum iron levels or serum ferritin levels. So basically that means blood iron levels. Okay, so basically over here your independent variable is your groups, your intervention group versus your control group, and your dependent variable is your blood iron levels. Okay, so you remember the action, two groups and then continuous. That is what it means. My apologies, it's my mom's phone. All right, so yes. So now the second thing which I wanted to show you is this is, we are not going to be practicing this, so this is just an FYI for you. This is independent samples t-test. Okay, meaning you have group 1 intervention group, and these participants are not repeated in your control group. Okay, so participants in your control group are different from participants in your intervention group. All right, so in this case you do an independent samples t-test. Now you have something which is called as paired or dependent samples t-test. All right, so when do you do this? All right, so over here you have the same participants which are measured twice. Okay, if you have more than 2 readings, then t-test is not applicable. Then you may have to do something like ANOVA. Okay, or there are other techniques as well, like general linear model and repeated measures. Okay, which we won't be talking about right now, but yeah, that is not something which you can do with t-test. With t-test, if you have measured your participant twice, then yes, you are right to do the same participant twice. Then you can do paired or dependent sample t-test. Meaning, for example, you measured your participants' blood levels, say at the start of the intervention, before they took the iron pill. This is called as baseline. Okay, so before they took any iron pill, you measured their blood iron levels. Then they took your iron pill for 6 weeks. And at 6 weeks, you finish your intervention. That is when you measured their blood levels again. All right. You did this for the intervention group. You did the same thing for the control group. All right. So every participant in your study was measured twice. Start of the intervention, end of the intervention. Now you do a paired sample T test to see whether every participant's blood iron level from the start till the end, did they improve, blood iron level improved, or it stayed the same, or unfortunately it decreased. Okay, so that is when you do a paired sample T test, when you have the same participant measured twice. All right. But as I said that in today's workshop or tutorial, we'll be only practicing independent samples T test. All right. Because as I said, this is not quantitative data analysis unit. So I can't show you all types of these tests and how to do them in SPSS and so on and so forth. But you will at least get some idea today. All right. Okay, so guys, again, we will do this in the SPSS sheet. So rest assured. But again, I'll just show you how do you write the results. All right. So over here, see, I have used the term on average, and I can correctly and rightfully use the term on average because now you know what does t-test do? It compares mean values, average values. So it is right to use the term on average. Okay. So on average, mean serum vitamin D levels were significantly higher among affluent participants. So this is again, this data which I'm showing, I have shared over here with you. This data is when I was doing my postdoctoral work in India, in Mumbai. And we had taken, you know how I gave you the example of the ladies who were wearing a burqa and they had a low blood vitamin D level. That's the same study. Okay, so this study is published. It is available in the literature. So basically in this study, what we saw was that yes, ethnicity had an influence on blood vitamin D level. The second thing which had an influence on blood vitamin D level was affluency. Okay, affluency meaning participants who attended private hospitals versus participants who attended governmental hospitals. So guys, now you will have to understand and appreciate. And of course, again, my apologies, this is more of a public health subject or this concept which I'm telling you, but it is good for you to know because you never know what sort of research and what sort of variables you end up studying. Okay. So in a developing country such as India, all right, you have normal middle class people like myself. Okay, so I'm a middle class person. We go to private hospitals. Okay, so we still have the capacity to afford private hospitals. So basically in developing countries such as India, private hospitals is where your white collar job people go. Okay, people who are earning a decent income, a decent living, they would go to private hospitals. And governmental hospital is services from governmental hospitals are taken by individuals who are most of the time below the poverty line, who are say living in slum areas, who cannot afford to pay any medical fees. That is when they go to governmental hospitals. Okay, whereas the concept over here is very different. Over here, because Australia has an excellent healthcare system and health equity for everybody, therefore people like us, at least me, okay, so people like me in Australia, we would be going to a public hospital, okay, and we would be receiving the same quality attention and care. All right. And individuals who may be say more affluent, they may be say seeking services from a private hospital over here. So this is a very, very different concept. All right. So that's why for you to not get confused with this example, it was important for me to give you a background. All right. So yes, over here you have affluent participants, meaning who are taking services from a private hospital. They had better vitamin D levels compared to non-affluent participants, meaning those taking services from governmental hospitals. And majority of the population in our study, they were from the urban slums of Mumbai. Okay. So now what do you write over here? Guys, this is the mean blood vitamin D level. So when you measure their blood levels of vitamin D, it is reported in nanogram per ml, okay, Ng per ml. So nanogram per ml of blood vitamin D. So affluent participants' blood vitamin D level were 12.6, for example, and this is plus minus standard deviation. You know how I taught you mean and standard deviation are best friends? Okay, so they are buddies. So this is what it means. Means and standard deviations you report together. Okay, whereas participants who were seeking services from a non-affluent background, their blood vitamin D levels were lower. This is 12, this is 10. Okay, and this is t-test. So basically the yes, the, you know how I told you Pearson's correlation has an R symbol. So in t-test the symbol is T. Okay, so t-test T. All right, it's easy. All right, T. And in the bracket what you have, this is called as degree of freedom. All right, again, what exactly is degree of freedom? All of that is part of quantitative unit. All right, so I won't go into the details of that because you will sleep otherwise. Okay, so I just this is just for your FYI that in the bracket the number which you have, that is called as degrees of freedom, and this over here is equal to 2.96. This is called as the T value. Okay, like you know how you had the R value, R 0.35, and bigger the R value, better the result. And now you can see in my PhD, I had a R of 0.34, not very strong, but it's okay. All right. Oh, I just noticed over here I have written 0.34, over here I have written 0.35, but you get the idea, right? So, but I'll correct this before I put it on your canvas. Okay. So yeah, coming back over here on this slide. So yes, over here the concept does remain the same. Higher the T value, better are the results, stronger are the results. Okay, so this T 2.96, the bigger it is, the better it is, but it is still not, this is still not an indicator of effect size. You know how R is a standardized value and you can compare across papers? Well, that doesn't go for T value. You don't compare T values across paper. There is a different technique of calculating effect sizes from T values. Now that is again amazing knowledge, but not required for epidemiology unit. Okay, but just an FYI, do remember that for T value, different way of calculating, say, effect size. But guys, basically, I have to tell this to you. This may be helpful for you. Is guys, the effect size of bivariate analysis is of little value when you are further doing multivariate analysis. The effect size which you gain out of multivariate analysis, that is the one which holds the final decision making. Okay, so yes, you have done bivariate analysis, you have effect size in terms of say R value if you do a Pearson's correlation, but it has little meaning because, as I said, bivariate in itself has little meaning. You have to then further this analysis with more sophisticated analysis such as multivariate analysis, and in multivariate analysis you again do have effect size, and those effect size, they hold much more meaning because they are controlling for a lot of variables. They are considering a lot of variables. The tests are more robust, so the findings are much more stronger. Okay, and those effect size are of greater value. All right, so that's why when people do t-test in regular papers, and you will see t-test would be done in a lot of papers where you have things such as say intervention group, control group, something basic like this. So basically people do t-test, but they don't go to the efforts of calculating effect size out of t-test because they know that they have to complement these results using multivariate analysis. Make sense? Okay. All right. So yes, the other way of writing the result is mean serum vitamin D concentrations were significantly higher. Now you know I have the right to use the term significant because I have actually done a test to show that there is a slight difference, 10 versus 12, but this is a significant difference because we have a p value for it. Okay, so significantly higher among affluent. In comparison to non-affluent participants, I have both of them written in the same statement. I do have my t value again, and I have my p value as well. All right. So guys, this is how generally you write results for t-test. All right. So I hope this has been helpful. So now moving to the last test that we will do as part of our tutorial workshop is Pearson's chi-squared test. And as I said, with chi-squared test, you don't have the concept of parametric, non-parametric per se, because both of your variables are categorical in nature. You have to worry about parametric, non-parametric, essentially for continuous variables in 99% of the cases. Okay, so that is where you have things of whether I should do Pearson's correlation or whether I should do Spearman's correlation. Okay, with chi-square test, you don't have to worry about that because both of your data, IVDV, are categorical in nature. Okay, so for example, over here you have gender, male versus female, and iron deficiency. Okay, are they deficient in iron or are they not deficient in iron? All right. So the answer which you get when you do Pearson's chi-square test, they are in forms of percentages and proportions. Proportion meaning frequency, like 10 people were iron deficient, which was say 90% of the population, and say 2 people were not iron deficient, and this was say 80% of the population, and you have over here 20% of the population. Makes sense? So the answers which you get out of Pearson's chi-square test, they are actual numbers. These are not averages, is what I want to say. Okay, in t-test we had average and we were doing statistics on average or mean values. Over here you do statistics on actual count. All right. Okay, and the symbol for chi-square test is this one. So you have an x and raised to 2, so it's chi. All right, so chi-square test symbol. All right, so yes, Pearson's chi-square test, and this will make more sense when I show you the SPSS output. But yeah, Pearson's chi-square test is generally used for a larger sample. All right, likelihood ratio test, which is something which comes up in Pearson's chi-square test, is used for a smaller sample, okay, which is less than 30, just an FYI. Okay, and bigger the chi-square value, stronger is the result. All right, so again, the same phenomena for T and for R, all of those values. Over here, you know how R is a indicator of effect size? With chi-square test, what chi-square test generates for you is odds ratios and 95% confidence interval. Now, this is an indicator of effect size as well. Odds ratios and 95% confidence interval. You know how I taught you last week is the concept of dispersion, okay? Meaning when you have narrower confidence interval, better is the result. When you have broader confidence interval, poor is the result, meaning low effect size. Narrow, strong effect size, okay, meaning greater variance explained. Okay, so now you know the concept of effect size, meaning that IV is explaining a lot of variance of the DV, okay, which is what I started when I started this tutorial, to explain you the concept of variance. Okay, so yes, the conclusion over here, take home message is that Pearson's chi-square test does generate an effect size for you. It generates an effect size for you by giving you odds ratios and 95% confidence intervals. Okay, and 95% confidence interval is the biggest thing which will help you to say, show whether the effect size is weaker, meaning broader confidence interval, or whether the effect size is strong when the confidence intervals are narrow. All right. So now over here, guys, basically, this is how there are 3 ways of writing the result. Okay, and this is my best option. This is how I generally write results when I'm writing it in my research papers for publication. Okay, but it just depends upon what how your tables look, what variables are there in your tables, and what do you want to report. Okay, so there is no A set style. All right, so yes, over here, for example, the results show a greater proportion of girls, and see, which is 75.9% of girls, which were say 167 girls. As I said, over here the statistics is on number. Okay, so actual number of people, 1, 2, 3, 4. So 167 girls made up 75.9% of the total sample. Okay, a greater proportion of girls were iron deficient in comparison to boys. So only 24% boys, meaning 53 boys were iron deficient, whereas 75.9% of girls were iron deficient. All right, this is your chi-squared. Again, in the bracket you have degrees of freedom. All right, and is equal to 30.01. This 30.01 is your chi-squared value. All right, and you have p less than 0.01. Okay, the other way of writing the same result is the prevalence of iron deficiency was greater among girls than boys, and then you actually just write the percentage, and then you have your chi-squared, degree of freedom, and p-value. All right, when is this style useful or favorable? when you have your n values, meaning this 167, 53, actually written in a table form. So table 1, table 2 of your research paper or of your manuscript. Okay, so that is when the second style is preferable. All right. So why is this the best option for me personally? Is because in my tables, when I do table 1, if I do chi-square, in my table, I have both the number and the percentage reported in the table. So table 1, table 2. And what I write as form of sentence structure result is the odds ratio and the 95% confidence interval. All right. So that's why I like this option, because all those numbers are in the table and my statement is only about the odds ratios and confidence intervals. Okay. So over here, girls were 2.79 times. Okay, meaning around, say, let's just say 3 times. Okay, so just for layman terms for you to understand. So girls were 3 times, and see, this 2.79 is actually the odds ratio. So when I show you the SPSS output, it will make more sense. So the odds ratio is 2.79, and see the number 2.79, all right, it lies between 1.92 and 4.04. Okay, it lies between that. Would you say this is a narrow confidence interval? Yes, I would say so, because when I look at the wider literature in this area, this is considered a narrow confidence interval, meaning it has a good effect size. Okay. So yes, girls were, say, 3 times more likely to be iron deficient in comparison to boys. See how easy it is to understand. This result is like so easy to understand, right? And do you remember odds ratios, where I said not to use the term risk, because you use the term risk in risk ratios, but you can use something like likely. Likely is the most neutral term. It's like Switzerland, and you can use it in risk ratios and odds ratios. Same thing applies over here. I have written my results with likely. All right. So girls were, say, 3 times more likely to be iron deficient in comparison to boys. You always have to report your chi-square degree of freedom p value, okay, in your sentence structure. All right. So yes, guys, this is how you write your chi-square test. I hope it's simple, because yeah, I've just tried to make it as simple for you as possible. Okay. So guys, over here, I have just shown you how the SPSS, this is my SPSS sheet, how it looks basically, but I have made this sheet much more simplified for you. All right, so I'll show you how it looks, these sheets which you have, and they are available on Canvas for you. As I said, please, if you're new to research, if you're new to quantitative data analysis, please download SPSS, okay, from Google for 14 days for a free version, and do all of these tests. Okay, so I would recommend that once you see both of these tutorials, week 3, week 4, then download, so that you have it for 14 days and you can do all of these tests, so you have some confidence and practice for doing the basic level quantitative data analysis. All right, so now I'll share the sheet with you. The first thing which we are doing is Pearson's correlation. Okay, so let me share the SPSS sheet for Pearson's correlation. Pearson's correlation share. So now you should be able to see the SPSS sheet, which is for Pearson's correlation practice. Okay, I have made 3 different sheets for you. I have not shown you my entire research data set, like, this variables are part of, say, 69 other variables. But if I give you such a SPSS sheet, you guys will faint, because it's like, you're still learning. So let's take baby steps and let's make it as simple as possible. All right. So I'll just make sure that, yes, so the sheet which you can see right now is for Pearson's correlation. All right, so guys, I told you have 2 variables. Pearson's correlation is for continuous variable. Both of these variables are continuous. So you have mother's pressure feeding practice and the child's fussy eating behavior. Okay, there is a bidirectional relationship among this. As I said, therefore, you cannot establish causation. Cause-effect relationship cannot be established. So now how do you do Pearson's correlation in SPSS? You go to analyze, then you go to correlate. Okay, analyze, correlate, you go to bivariate. All right, you open bivariate. Your sorry, I was doing this previously, so everything is on that side. I'll just reset it for you. All right, so you take both of your variables this side. Okay, that's all you do. Pearson's is automatically ticked for you. Okay, you don't have to do anything about it. Everything else is done. You just have to do one thing. Bring your variables on this side. That's it. This is like the as simple test as possible. Okay, and then you press OK. And now we will look at the output. I have to share the output with you. I I have to remind myself like this so that I'm not just talking and you cannot see it on the screen. So I have consciously made it a point to keep talking so I can show you. Okay, so guys, this is how your SPSS output will look. All right. And I have copy pasted the same SPSS output in your PowerPoint. Okay. So why? Because there are few variables which I want to walk you through, and it will be easier to highlight them, color code them on the PowerPoint. All right. So I just want to show you this is how your SPSS output looks. The same thing is copy pasted in your PowerPoint slide. So now we will go on to the PowerPoint slide. All right. So let me just share the PowerPoint slide with you. Okay, so guys, this is how the SPSS output looks. Okay, so this is your Pearson's correlation, meaning your R value. Okay, as you can see, the R is positive. And when you have these little stars over here, you become happy. I mean, I become happy because it means that my result is significant. Okay, so yes, having significant results makes me happy. All right, so yes, you have a positive association, meaning mothers who are pressure feeding, their children are more likely to be fussy eater. There is a positive association, direct association. This is my significant, okay, p value. As you can see, it is 0, 0, 0. How do I write this result? P is less than 0.001. That's how you write it. Okay. My sample size is 203. Okay. So this is on 203 mothers and children. Okay. So that is my sample size. All right. So the same result is over here. Okay. Because I just have two variables. It is either you correlate pressure feeding with fussy eating, or else you correlate fussy eating with pressure feeding. It's going to give you the same result. All right. So yes, these double stars over here, it means correlation is significant, all right, at two-tailed test. All right, so yes, guys, this is what I wanted to show you. It's as simple as this. So Pearson's correlation is not really rocket science. So now we'll go on to independent samples t-test. Again, I'll show you how to do it in SPSS. We'll talk about the output in your PowerPoint slide because it's easier for me to highlight these things. Okay, so let me share the t-test data sheet with you. So all of this is available on your canvas. Okay, so I have labeled this as t-test. So it's easier for you to identify which SPSS sheet is for t-test, Pearson's correlation, and chi-squared. All right. So now with the t-test, there are two variables. As I said, with t-test, you have categorical variable with two categories, and you have a continuous variable. Okay. So over here, you have the socioeconomic status. You know how I said private hospital versus government hospital. So over here, this is called private hospital. And this BMC is government hospital because it stands for Bombay Municipal Corporation. Okay, meaning these are, say, sectors of governmental hospital in India. So as I said, this is a real data set, but because I have published out of this data set, I can definitely use it for teaching purposes. All right. And similarly, the earlier data set was from my PhD. So again, that is my own copyright. Okay, so I can use that. All right, so now guys, we will do the t-test. So you go to analysis, you go to compare means, and then you go to independent samples t-test. Okay, analysis, compare means, independent sample t-test, and then I'll just reset it for you again. So this, if you remember, I had taught you this flower shaped thing over here, that is your categorical variable. You take it to the grouping variable. So categorical variable should be placed over here in grouping variable. And I have two categories, private hospital and the government hospital. And the coding which I have given in this is 1 and 2. Okay, 1 for private, 2 for government, like that. All right. And then I have the blood vitamin D levels. All right. So our main research question is people going to the private hospital, do they have a better vitamin D level than people going to the government hospital? Yes or no, sort of a thing. Okay. And then let me see if you have to do anything in options. No. Okay, so that's it. You just bring the variables on this side because I'm just teaching you the most simplified versions of everything. And then you press OK. All right. And then how your SPSS output will look, as you know, is the one which is in your PowerPoint slide. So now we will directly go on to the PowerPoint slide. It just makes our life simple. Okay, so rest assured, this is how your output will look in your SPSS sheet as well, output sheet. All right. So, okay, so over here I have, there were say 68 mothers. So this was on mothers. Okay, this was also on mothers. So 68 women basically, not just mothers, but women. Okay, 68 women were attending the private hospital and 82 women were attending the government hospital. All right. And as we had seen, if you remember the writing of t-test, private hospital, their average blood vitamin D levels were 12. Okay, I'll just go with whole numbers over here. So average blood vitamin D levels for women going to private hospital, 12. The average level for women going to government hospital is 10. So now do you understand the N and means? And of course, if you remember, I had taken standard deviations in my result as well. Okay. So this red color circle of mine should be till standard deviation. Basically, what I want to indicate is these are the three important things which variables you may need for say reporting your results in tables, writing, all of that stuff. Okay. So yes, N value is important, mean is important, and standard deviation is important. All right. So just to keep it simple, mean and standard deviation is what is reported. But remember, in some research papers, some authors also report mean and confidence intervals. Okay, because as you know, confidence interval is a indicator of effect size. And if you don't really want to calculate another step of effect size out of this, it is a good idea to report confidence intervals. Okay, so some papers do that. Some papers report mean and standard deviation because they know they are going to do multivariate analysis. So this does not really make a lot of difference. So for example, my practice is generally I report mean standard deviation because I know I'm going to do more sophisticated multivariate analysis after this. All right, so there is no one standard way. It depends. All right. So now your significant results are over here. You take two-tailed significant result. Okay, so it is P is equal to 0.004. This is your degree of freedom. This is your T value, which were reported in your writing. So now you know where do you take these results from. Okay, this is where you take the results from. Makes sense, guys? Okay, so this is as simple as it can get. Now we'll look at the chi-squared test, how to do this in SPSS, and then we'll again come back to this. All right, so now I'll show you the output for chi-squared. So I'm sharing with you chi-squared test SPSS sheet. All right, so guys, again over here, as you can see, it's written over here that this is the chi-squared SPSS sheet. All right, so it will be easier for you to identify. Now remember over here, both of our variable are categorical in nature. Okay, so I have males versus females, and then I have iron deficient versus non-iron deficient. Okay, so I go to analysis, I go to descriptive, and then I go to cross tabs. Okay, so now in cross tabs, I'll again reset it for you. So I take my iron deficient over here, I take my gender over here. All right, and then okay, I don't do anything in the first extract. In statistics, you have to take, you will have to take, okay, chi-square you have to take, and you have to take Crokin and Mantel-Hassel test. Why? Because that will give you odds ratios. Okay, so for you to get odds ratios, you need to take this. All right, so take chi-square, take this. This is to the minimum, you know, the minimum thing which you need. All of this is, if you are learning quantitative analysis, that is when all of this would be explained better. Okay, so right now just basic is chi-square and your odds ratio test. Okay, you press continue. Within cells, all right, you this will be automatically ticked for you. You have to take row, column, total, percentages. I like having percentages for both my rows and columns because then it makes more sense to me that which is the one I want to report. Okay, so that's just my best practice, which is I take rows, columns, and total. Observe, this will already be ticked for you. Okay, you just press continue. So remember, you go to statistics, you take chi-square and Croken-Hazel, continue. You go to cells, you take rows, column, total, continue. Okay, so as simple as it can get. All right, and then you press OK. All right, and now how your output will look is what I have copy pasted for you in your PowerPoint slide. So I'm sharing with you the PowerPoint slide. Okay, all right, now I've shared with you the PowerPoint slide. So now guys, over here, as you can see, again, this data is from that actual research which I had done in, this was also actually in Mumbai when I did my postdoc in Mumbai. So guys, this was a very interesting research which I had done. We had looked at tribal children in Mumbai. So these tribal children, they were living at the outskirts of Mumbai. So in Maharashtra, I shouldn't say Mumbai. And these tribal children, we were giving them biofortified Indian bread. So Indian bread is called as chapati or roti or naan. Most of you must be acquainted with that term, naan. All right. So these were biofortified with iron and zinc. Okay. And these naans were made from specific type of millet. So if for non-nutrition student, what is a millet? It is something like say wheat, okay, or barley and oats and stuff. So it's kind of a cereal. All right. So basically these iron fortified naan were made, iron and zinc fortified. And then we wanted to see whether this improves their blood levels of iron, blood levels of zinc, things like that. Okay, so basically this was another study which I had done during my postdoctoral time. We also saw if it improves their cognitive capacity, physical performance like running and athletic performance for these tribal school children. So it was very interesting study. These were adolescent children, so adolescent girls and adolescent boys. Okay, so yes, now guys, I have complete data on 578 children. All right, so boys, girls, everything combined. Missing data is 175. So all of my statistics, which is done by SPSS, is on 578 children, because for these 578 children, I have both of the things reported, meaning are they male or female, and what is their blood iron levels. When I have both of these variables reported, that is when you can do the analysis. Okay, so that's why I have complete data for 578 children. So now you know what does complete data mean. Okay, meaning you have complete data on both of these variables. So now guys, I want to show you basically what I report in my tables, because this was say I have published this. So what I had reported is, for instance, is males and females, how many are iron deficient. See, if they are non-deficient, it's good. I'm not interested. Okay, I'm interested in how many kids are iron deficient. All right, so now within iron deficient, I can see 75.9% of girls are iron deficient, 24.1% of boys are iron deficient, and this adds up to 100%. So that's why it's color coded for you. Okay, just for your FYI. All right, so basically in my tables, these are the numbers I report. So many girls are iron deficient, so many boys are iron deficient, which adds up to 100. Okay, this blue color is to just tell you that if you do a within gender count, then this is 46, and this is say girls within girls, you mean just within girls, 46% girls are iron deficient, 53% non-deficient. This adds up to 100%. But no, that is not useful for me, because I want to see between genders, between girl and between boy. All right, so that's why I look at this golden one. All right, so the numbers I report is this: 167 girls, meaning 75.9%, 53 boys, meaning 24.1%, are iron deficient. So those are the numbers I select for my reporting. I hope this has been useful. There are, depending upon your research question, these percentages may vary. See, your count is the same. All right, the count you use for iron deficient would be the same. Okay, your percentage may vary depending upon what is your research question. My research question is, are girls more deficient or boys more deficient in iron? So that's why I'm selecting this golden row. Okay, so for me, girls are more deficient than iron. These are the numbers and these are the percentages. Make sense? Okay. So the next thing which is reported in your output, chi-squared output, is your Pearson's chi-squared value. You know how I said you have a chi-square value, you have a degree of freedom. So this is where you take the answer from, all right? And you take two-tailed significance, all right? So that's why you have it over here. P is less than 0.001. That's how you would report this result, okay? You know how I said you like the likelihood one you use for a smaller sample and things. So that is all I would use. As I said, if I were to teach you quantitative data analysis, I would be using those things over here. So I would love to teach quantitative data analysis, like, as one of the subjects in the future, because I just love quantitative stats. And that's what I use predominantly in my research. But yeah, let's teach epidemiology at the moment. Okay. All right, guys. So this is the odds ratio. So let me just move my video screen that side so I can see as well. All right. So guys, this estimate which is written, that is your odds ratio. If you remember this statement structure, it said 2.78 was the odds ratio, right? 2.79 because I rounded it up. So that is where you get it from. So 2.79 times we had written girls were more deficient than boys. That is where the number comes from. And then you have your effect size in terms of confidence interval. So this is the confidence interval which I take. Okay. So does that make sense, guys? So these are basically the key things which you have to take and consider when you do a Pearson's chi-squared test. All right. So now, guys, as an activity, what I would recommend you to do is, rather than giving you a separate data set to practice on, I would request you that you have these 3 data sets, okay? Once you have seen the tutorial, practice on these 3 data sets, Pearson's chi-squared, t-test, and you have your Pearson's correlation. Practice this and then see whether your answers are same as mine. That's why I didn't want to give you a different data set, because for those students who are doing bivariate analysis for the very first time, if you practice on the same data set, you will get the confidence that, oh yes, my answers are similar to what has been provided. So that will give you further confidence to work on your own real life data set in the future. Make sense, guys? All right. So, okay, so that is the activity for this workshop or this tutorial, is for you to practice these 3 bivariate analysis. Okay, and yeah, try writing down the results as well. Okay, don't just do the SPSS output and be happy. Try to write down the result, because it is very challenging when you are just learning to make sure that you are writing all the appropriate numeric values and you have considered everything, t-test, degree of freedom, all of those things. Okay, so please try writing down the results as well. All right, because then you will understand how do you frame your words. Okay, are you more say leading towards using cause, or are you using the right terms such as association or correlation, all of that. Okay, so yes, guys, that's it.